Dashboards showed yesterday's data until 10 a.m., causing missed revenue alerts. A schema change broke the static insert select script. Dashboards showed yesterday's data until 10 a.m., causing missed revenue alerts. The culprit? A static insert select script that broke when the source table added a new column. Here's exactly why that happened. In this lesson, we'll explore Snowflake Dynamic Tables, a declarative way to build data pipelines that automatically refresh as source data changes. No more cron jobs or manual scheduling. Dynamic tables give you declarative data pipelines. You define a transformation with a simple SQL query, and Snowflake automatically keeps the result, your target output, up to date with no manual scheduling needed. Whether your source data comes in batches or streams, it just works. Think of it like a smart grocery list that updates itself. Creating a dynamic table is straightforward. You write a create dynamic table statement with a target lag and a warehouse, and the Snowflake engine keeps it refreshed. The query can include joins, aggregations, and more. Here's a real example. A dynamic table that aggregates sales by hour using date_trunc on order time. It refreshes every 5 minutes, so your dashboard always shows fresh data. The target lag parameter controls the staleness of the dynamic table. Shorter lag means more refreshes from the refresh scheduler, and you can monitor refresh history to tune performance. For immediate fresh data, manual refresh is also available. This query shows the refresh history for a dynamic table. You can see when refreshes started, ended, and whether they succeeded. Dynamic tables use change tracking for incremental refreshes, applying only deltas and avoiding full scans, though not all queries support this. You can check whether a refresh was incremental or full using this query. If you see many full refreshes, review your query design. You can alter a dynamic table to change its target lag or warehouse, suspend or resume automatic refresh, or clone it for testing. Dropping it removes both definition and data. Let's walk through management commands. You can adjust the target lag to 30 minutes, pause refreshes during maintenance, and create a clone for development. Looking at the comparison, dynamic tables support joins and complex SQL, unlike materialized views, but are simpler to set up than Streams+Tasks. Notice how the materialized view uses date_trunc on a single table, while the dynamic table, with a target lag of 1 hour, can join multiple tables and still refresh incrementally. For production, start with a target lag of 5 to 15 minutes, use a dedicated warehouse, cluster on frequently filtered columns, and monitor refresh history. Clustering can speed up refreshes by organizing data on disk. This command adds a clustering key on the order date column. Here's the chain reaction. The developer assumed the cron job would always run, but when the source table added a new column, the static insert select script broke. No retries, no alerts, just stale data. We fixed it by connecting to the source table and replacing cron with a dynamic table. It adapts to schema changes automatically, so a new column won't break the pipeline. No manual retry logic needed, it recovers on its own. Automatic incremental refresh, controlled by target lag, keeps your dashboard data fresh. Using select in a static script is fragile. When the source table adds a column, the column count mismatch causes the insert to fail. Dynamic tables handle this automatically. A target lag of 1 second forces near-continuous refreshes, which can spike costs. Start with 5-15 minutes and adjust based on monitoring. With a target lag of 5 minutes, non-deterministic functions like current timestamp prevent incremental refresh. Snowflake falls back to full refresh, increasing cost and latency. When a dynamic table isn't refreshing, start by checking the refresh history for errors. Then verify source tables are accessible and consider adjusting the target lag, for example, setting it to 5 minutes, or increasing the warehouse size. Interview prep time, interview questions. Dynamic tables are a key SnowPro topic, so understanding these differences matters. Let's walk through frequently asked questions about dynamic tables. To recap, dynamic tables automate data pipelines with declarative SQL. Set a realistic target lag, design for incremental refresh, and follow best practices for production success. Thanks for watching. The full article and code examples are covered in detail at thecodeforge.io.